Hello everyone. Today we'll talk about the trigonometry. One of the part of this trigonometry is understand the right triangle properly. So we'll talk about the right triangle. Okay. What is right triangle? When one of the triangle has a 90 degree, one of the angle is 90 degree. It's called right triangle. So the opposite of the 90 degree is called hypotenuse. Opposite sides of the right triangle of 90 degree is called hypotenuse. Then let's say we assume there is a angle theta c, so the opposite of this angle theta actually called opposite. Okay, and the other side of the triangle is called adjacent. Now it's very important to understand this part. So um, here, so hypotenuse we got AC, right? Adjacent we got BC, and the opposite we got AB. Okay, so hopefully everyone, all of us knows the Pythagorean theorem. Pythagorean theorem is when we square the hypotenuse, right? Then it's gonna be equal to opposite square plus adjacent square. So I already have it here, this. So if you do the opposite square plus adjacent square, we got the hypotenuse square. So that's mean if we, what is the opposite here? Our opposite is AB, right? So AB square plus adjacent is BC, BC square equal AC square. That's mean opposite square plus adjacent square equal hypotenuse square. Let's do some real quick the math. So let's say if we have let's say we have a triangle. So let's say in triangle ABC we have let's say AB equal 5 meter. Let's say AB equal, let's say this one just to make fun. AB equal 4 meter. Then BC equal, let's say BC equal 3 meter. Then what's the value of AC, which is hypotenuse? So let's say if we get this type of question, right, how are we going to approach it? So first we're going to use the formula. We already know that opposite square equal adjacent square, opposite square plus adjacent square equal hypotenuse square. So that's mean let's just write it down, AB square in this case plus BC square equal AC square, right? So what is our AB here? AB, it says 4 meter. So 4 square. BC says 3 meter. So 3 square. And AC is unknown, right? So let's do it. So 4 square is 16. 3 square is 9 equal AC square. So 16 plus 9 is 25 equal AC square. Now if we do square root in both sides, we got square root of 25 is just 5, AC square is just AC. So this is the answer. So AC will be 5 meter. You see, with the Pythagorean theorem, if we have in right triangle, if we have two sides and you have to find the other side, you can find it easily. Okay, now I really want you guys to understand that part because it is very important. Also I think you guys also need to know about the opposite square plus adjacent square is the hypotenuse square. It's very, very important. Okay, so once we know it, Now let's go to our let's go understand about the three trig functions. With these three trig functions we can find out the relationship of right triangle between the sides of right triangles and the angle of the right triangles. So let's go to six trig function. The six trig function we have, they are actually sine, cosine. Let's just make it here different color. Sine, cosine, tangent, cosecant, secant, cotangent. Okay, these are the full form, but usually when you do the math we don't write down the full form, we write down the short form. Okay, for the sine we just write down sine, for the cosine we just write down cos, for the tan we just write down tan, for the tangent we just write down tan actually. For the cosecant we just write down cosec, and for secant we just write down secant, and for cotangent we just write down cotangent, cot, right? Here cosecant, for cosine we just write down cos. So once we know this part, now we're gonna draw a triangle, right triangle, and we're gonna find out the relationship between the angle and the thetas. Okay, and the angles and the sides of the triangle. So let's think about this triangle. Okay, this triangle we have ABC. It's a right triangle because it's one of the angle is 90 degree. That means it's a right triangle. The opposite of this 90 degree is, we already know, the hypotenuse, opposite and adjacent, right? So let's think about this is theta, right? So if we do sine theta, we actually get opposite over hypotenuse. So here opposite is AB, our hypotenuse is, so here we got opposite over hypotenuse. Okay, that's mean it's sine. If we take this, the first letter of sine is S, and the opposite is O, and hypotenuse is H. This is just to remember, we can just use this. So for cosine is adjacent, adjacent over hypotenuse. Okay, hypotenuse for the cosine. So you can just write down the cosine is C, adjacent is A, hypotenuse is H. It's the short form so that we can remember it. It's one of the popular short form. For tangent, tan theta, we got hypotenuse, we got opposite here, opposite AB. Then we got hypotenuse, which is H, right? We got hypotenuse, which is, so for tangent theta, sorry, is this opposite over adjacent, which is BC. So you can just write down tan is T, opposite is O, adjacent is A. So you see, if we write it down, we got so ka TOA. Is it for sine, cosine, and tangent? We can just easily relate this so ka TOA. S means sine, so any angle of sine is just opposite over hypotenuse. Any angle of cosine is adjacent over hypotenuse. Any angle of tangent is just opposite over adjacent. Now here is the interesting fact for the cosecant, right? Let me just change the color. For cosecant, we have hypotenuse over opposite. That means it is exactly opposite of sine theta. You see, because sine theta is opposite over hypotenuse. If you flip it, you get 1 over sine theta, and you get hypotenuse over opposite, which is cosecant theta. Same thing with the secant theta. That's why I write it down side by side. It's just 1 by cos theta. You see, cos theta is adjacent over hypotenuse, right? So secant theta is just hypotenuse over adjacent. This means the opposite of cosine theta. For cotangent theta is the same thing as the tan theta, cot theta, right? So it is just gonna be 1 over tan theta because it's also the opposite of cotangent theta. You see, it's pretty easy when you look like that. Look over this. It feels pretty easy, right? Now let's just do, I'll make it smaller, and let's resize it. Let's just make it smaller, a little smaller. I don't know why it's like this. Let's just do it here. So let's just do an example. Okay, so let's let's just have, let's say, in triangle, this ABC triangle, right? This ABC triangle. So let's just, this ABC triangle, triangle. We have, let's say, we have let's say AB equal 5 meter. Then let's say AC equal 10 meter, let's say. What's the angle C? So let's say if we have this, what's the angle C? So if we have this kind of question, how are we going to approach it? So we have AB. What is AB here? AB is what? AB is our opposite. So we have AB equal 5 meter, which is, we can just write down the opposite. Then we have here AC. It says here 10 meter, which is actually the hypotenuse, right? So remember, so OH, which one goes with OH? You see this SOH, TOA? So we can use the sine, since we have to find out the theta, right? Because angle C is actually the theta. So we can use the sine as so sine conversion. So let's just do sine theta is what? Opposite over hypotenuse, right? So opposite. So you can just write down AB over hypotenuse, which is AC. Now let's write down sine theta equal, what is AB? AB is 5, AC is 10. So we got sine theta, since 5 is times 1 is 2, let's just do it, 1.2. So now we got the sine theta is 1 over 2, but we have to find out the theta. So we can just write it down, theta equal sine inverse 1 by 2. So when we try to find the angle, we can just do the sine function inverse. In other, sine inverse of half is just 30 degree. For here, since we don't have the limit, we just assume that it's between first quadrant. If it's the first quadrant, so sine theta is 30 degree. We'll discuss it in other chapters. So let's just assume that sine theta equals 30 degree, sine inverse half is 30 degrees. So theta is 30 degrees, so angle C is 30 degrees. You see, now if you have two sides, and then you can find out in the right triangle, then you can find out the one of the angle easily. Now if they ask you angle C and angle B, now since you already know the angle C, if they ask you angle C and angle A, since you know the angle C, now you can just do that, angle A plus angle B plus angle C is what? 180 degree, right? So now you can just plug in there and you can find out you have to find out angle A. You know angle B is 90 degree, then angle C is 30 degree, and this is 180 degree. So if you do the calculation, you will find out angle A is just 60 degree. You see, it's pretty easy, right? Now, since you guys understand that, I want you guys to remember this SOH TOA, so that way you can do any type of math. It will be easy for you guys. Okay, let's do now. Let's do another one, which is, let's say if they give you a triangle, this triangle we just talked about. They give you a triangle, right? And they ask you to find out the formulas. Let's just draw a triangle again. Let's just assume this is 90 degree, okay? 90 degree. So let's say A, B, C. Now, let's just say they say this is 5, this is 3, this is 4. Now if they ask you, they find out the trig property of these functions. How do you do that? So let's just do sine theta, cosine theta. Let's write it down first. Then tan theta. Right? So what is sine theta? Sine theta is just opposite over. Let's say this is theta. Okay, forget to write it down. This is theta. So if this is theta, then what is sine theta? We know sine theta is just opposite over hypotenuse, right? So it's going to be 3/5. Now the cosine theta, what is cosine theta? Cosine theta, we know there's adjacent over hypotenuse, right? So what is our adjacent? Is 4, because BC is the adjacent, hypotenuse is 5 again. So 4/5. What is tan theta? Tan theta is just opposite over adjacent. So 3/4. Now, when you do the other of them, right? Cosecant theta is just, if you can just do the opposite of sine theta, which is, you can flip the sine theta and you find out, or you can just write it down. What is opposite of sine theta? It's just hypotenuse over opposite, right? What is hypotenuse here? 5, and the opposite is 4. You see, secant theta will be the same thing. 5/, sorry, I made a mistake here, just to make sure, because our here cosecant theta, our hypotenuse is 5, but the opposite is 3, right? For secant theta, our hypotenuse is 5 and opposite is 4. And cotangent theta, right? Cot theta is just adjacent over opposite. You see the relation between them, sine and cosecant, is just the flip. They flip each other. Secant and cosecant is just flip each other. Cotangent and tan is the flip. It's 3/4 and it's 4/3. Okay, so I want you guys to understand this part. This is very important. I want you guys to understand this is very properly. Now, did you guys notice something? Look, what is tan? Tan theta is what? Is what it says? It says opposite, right? Opposite over what? Adjacent, right? Adjacent, right? Now, if we divide in the top and bottom both side by hypotenuse, what happened? So let's just do this one. Let's just divide by hypotenuse. Hypotenuse, right? And the same thing here. Hypotenuse. Since you cannot just divide one part hypotenuse in a fraction, you have to divide both part of the fraction, right? So what do you know? What is the opposite over hypotenuse? Opposite over hypotenuse is sine theta. So in the top, we can just write down sine theta. The same thing. What is adjacent over hypotenuse? It is what? It is cosine theta. So cosine theta. You see? Notice the difference? So actually, tan theta is what? Tan theta is just sine theta over cosine theta. So what's going to happen with cot theta? You just flip them. So it's going to be cosine theta divided by sine theta. You see? It's pretty easy when you look at this very slowly. You understand how it works. Once you understand SOH TOA, then you can just do any trig functions. You can just you can just manipulate them and just find out the relationships in between them. It's pretty obvious. Now let's talk about some of the formula you might use in here. So remember that we know for this, let's say for this triangle, right? What we have here, we already know that the adjacent here is BC, right? And the opposite is AB. So let's say AB square equal plus adjacent is what? BC. BC square equal hypotenuse is AC square. You see that? It's pretty easy, right? Now, what happened when we divide by AC square both sides? So AC square, let's do here, AC square by AC square. What do you get? We just divide that. What do you get then? We get AB square by AC square. So we can just write down AB by AC square. Then we can just write down BC by AC square. And here AC square and AC square is just going to be 1. Okay. So now what do we get here? We get, what is AB? AB is what? AB here is the opposite. So it's just opposite. Sorry, it's just opposite over hypotenuse. Right, I'm going to write down hypotenuse square. Then BC is what? Adjacent over hypotenuse. I'm going to just write down HYP, okay? Short form. This is 1. But what do we know? What is opposite over hypotenuse? It's just sine theta, right, in here. So it's just sine squared theta. And what is adjacent over hypotenuse? It's just cosine theta. So cosine squared theta. So it's going to be 1. So this is one of the formula. In your exam, you might see that you get asked that prove it, sine squared theta plus cosine squared theta is equal to 1. But it is one of the formula we're going to use it. So I want you guys to memorize it. But in the same time, I want you guys to understand where did it come from, right? So if they ask you to prove this, you can just you can just do it by this way. Or let's say they ask you to prove, let's say they ask you show that sine squared theta plus cosine squared theta equal 1. So it's a there is various way you can do that. You can just draw the triangle and write down the Pythagorean theorem, then just do it that way. You can do it, or you can just write it down here left hand side. what is the left hand side here? Sine squared theta plus cosine squared theta. So you can write down sine squared theta plus cosine squared theta. Okay, so now you have sine squared theta and cosine squared theta. What is sine squared theta? Sine squared theta. Sine squared theta is just opposite. So you can just write down opposite over hypotenuse. Let's just write hypotenuse as HYP. So opposite square over hypotenuse square. Then here cosine square theta is adjacent square divided by hypotenuse square. You can write down this way too. So what is opposite over hypotenuse? Opposite square, adjacent square, even hypotenuse square, hypotenuse square. You see that the denominator is, both of them is hypotenuse square. So you can just write down hypotenuse square, and in the top you can write down opposite square plus adjacent square. Now, what is opposite square plus adjacent square? In the Pythagorean theorem, what do we know? Remember, what do we know? We know that, opposite square plus adjacent square is hypotenuse square. So in the top we can just write down hypotenuse square. Now hypotenuse square. Sorry, I wrote it down wrong here. There should be y here. Hypotenuse square. In the down is, you have also, let me just do it again. So opposite square plus adjacent square is just hypotenuse square, right? In the down you also have hypotenuse square. So that's mean this cancel out. You just got 1, which is what? Which is right hand side. Exactly, our right hand side, right? We just write right hand side. So yes, so you can just find out sine squared theta, cosine squared theta this way. You can find all of them. So, and sometimes they might ask you, let's say they have this, then they're gonna ask you other part, like what happened, they might ask you, we have others formulas, so where do we get from the other formula? So we can just make it sine squared theta plus cosine squared theta equal 1. So from here we can find out 2 other formulas that will comes handy for our next exam and next trig functions. So if we do from here, so let's just do, we have sine squared theta, cosine squared theta, right? Let's first divide sine squared theta both sides. So it's going to be sine squared theta plus, you have cosine squared theta, and again sine squared theta, then 1 over sine squared theta. So first we divide by sine squared theta in both sides. So what do you get? Sine cancel. So you just get 1 here. And cosine and sine. What is cosine and sine? Remember, cosine and sine is what? So remember we did 10 is what? Tan theta in terms of sine theta and cosine theta. We got sine theta divided by cosine theta, right? So what is cot? It's just cosine theta divided by tan theta. Do you guys remember? So if you guys remember that, so you see that cosine and sine is the same thing. So you can just write it down, cot squared theta. Now, what is 1 over sine theta, sine squared theta? Remember that cosecant theta is just 1 over sine theta. So you can just write down cosecant theta. So this is one of the formula. You can memorize it, or you can um, you know how to drive it, so it will come handy when you do trick future reference for future reference. So this is one of the formula. So I want you guys to understand this. Most importantly, how we drive it, so that you don't have to memorize it. At least you know how to do it, okay, in the exams, or you know, or quizzes, if you get this, or your homework. So now, let's say we did this. Now they ask you that, if they ask you to drive another formula, which is tan squared theta plus 1 is secant squared theta. So how do you do that? For that, we have this formula, sine squared theta plus cosine squared theta. Now this time we're gonna divide this function in both sides with cosine squared theta. So cos squared theta, we're gonna divide this in both sides. Cos squared theta equal 1 by cos squared theta. So you see, this time sine squared theta plus cosine squared theta. We already know tan theta equals sine theta plus cosine theta. So sine squared theta plus cosine squared theta is gonna be tan squared theta, okay? Plus cosine squared theta cancel out, so you just left with 1. What is 1 over cosine theta? 1 over cosine theta is sec theta. You see that? Sec theta. So you can just write down sec theta. Excuse me. So yeah. So here you go, your formula. It is tan squared theta plus 1 equals secant squared theta. You see? So it is very important that we understand all of them. So far, what did we learn? What do we learn? We learn 6 trig function, which is one is sine theta, sine, cosine, tangent, cosecant, secant, and cotangent, right? Then this is the right triangle. Then this is very important, SOH TOA. What is SOH TOA? SOH TOA, you can just do s start with s. So which function is start with s? Sine. So you can just write sine theta. If we look at this triangle, got so OH, opposite over hypotenuse, right? So opposite over hypotenuse for sine. Cosine is adjacent over hypotenuse, and tan theta we got opposite over adjacent. You see? Excuse me, sorry. For cosecant theta is just opposite of sine theta, secant theta is just opposite of cosine theta, and cotangent theta is just opposite of tan theta. They are like vice versa. You can flip each of them. Now we know opposite square plus adjacent square equal hypotenuse square. From this formula, we can derive these 3 formulas. These 3 formulas is very important. I want you guys to write it down, and when you can, you guys can just have you guys can take a few pictures of it, so that you have it as like this sheet, so you guys will have better understanding of knowing this. Okay, so thank you guys. Have a good day. We'll do some of the problems in the next videos to show you guys how